Now that we know the basic operations on the list and how to create a specific list element, we can describe the class implementing a list as an array and the algorithms to implement the list operations. The following statements define the class ArrayList class as an abstract data type or ADT as shown in figure 2-4. The ArrayList class is an abstract class and it is a superclass of the classes that implement a list. It has three instance variables. Length specifies the number of elements currently in the list. Max size specifies the maximum number of elements that can be processed by the list. List an array of reference variables. Figure 3-4 is the UML diagram of the class ArrayList class. Notice that the instance variables of the class ArrayList class are declared as protected. Moreover, notice that the methods search, insert, and remove are declared as abstract. This is because of the following reasons. In general, we deal with two types of lists. Lists whose elements are arranged according to some criteria, such as sorted lists, and lists whose elements are in no particular order, as in unsorted lists. The algorithms to implement the operations of search, insert, and remove differ slightly for sorted and unsorted lists. Therefore, we define the class ArrayList class as an abstract class. By using the principle of inheritance from the class ArrayList class, we in fact derive two classes, unordered ArrayList and second ordered ArrayList. Objects of the class unordered ArrayList arrange list elements in no particular order. That is, these lists are unsorted. On the other hand, objects of the class ordered ArrayList arrange elements according to some comparison criteria, usually greater than or equal to. That is, these lists are in ascending order. Moreover, after inserting an element into or removing an element from an ordered list, the resulting list is ordered. We therefore separately describe the algorithm to implement the operation search, insert, and remove for unsorted and sorted lists. The next section describes these operations for unordered lists. We will deal with sorted lists because each of the classes unordered array list and ordered array list provide separate definitions of the methods search, insert, and remove. And because these methods access the instance variables to provide direct access to the instance variables are declared as protected. Next, we write the definitions of the non-abstract methods of the class ArrayList class. The list is empty if length is 0. It is full if length is equal to max size. Therefore, the definitions of the methods is empty and is full are these are the definitions of the methods is empty and is full. The data member length of the class stores the number of elements currently in the list. Similarly, because the size of the array holding the list item is stored in the data member max size specifies the maximum number or the maximum size of the list. Therefore, the definitions of the methods list size and max list size are the following. each of the methods is empty, is full list size, and max list size contain only one statement, which is either a comparison statement or a statement returning a value. It follows that each of these methods is of big O at 1. The member method print outputs the elements of the list. We assume that the output is sent to the standard output device. The method print uses a loop to output the elements of the list. The number of times the for loop executes depends on the number of elements in the list. If the list has 100 elements, the for loop executes 100 times. In general, suppose that the number of elements in the list is n, then the method print is of big O of n. Following is the definition of the method is item at equal. Public boolean is item at equal with parameters int location and data element item. There is only one statement in the body of method is item at equal, a comparison statement, and it is easy to see that the method is of big O of 1. The method insert at inserts an item at a specific location in the list. The item to be inserted and the insert location in the array are passed as parameters to this method. In order to insert the item somewhere in the middle of the list, we must first make room for the new item. That is, we need to move certain elements one array slot to the right. The number of elements currently in the list is 6, and so length is 6. Thus, after inserting a new element, the length of the list is 7. If the item to be inserted, say, is at location 6, we can easily accomplish this by copying the item in list at index 6. On the other hand, if the item is to be inserted at location 3, we first need to move elements list at index 3, list at index 4, and list at index 5, one array slot to the right to make room for the new item. Thus, we must first copy list at index 5 into list at index 6. Then, list at index 4 into list at index 5. And list at index 3 into list at index 4. In this order. Then we can copy the new item into list at index 3. Of course, special cases such as trying to insert in a full list must be handled separately. Some of these cases can be accomplished by other member methods. The definition of the method insert at is as follows. Mali ito. The method insert at uses a for loop to shift the elements of the list. The number of times for loop executes depends on where in the list the item is inserted. If the item is to be inserted at the first position, then all the elements of the list are to be shifted. It can be easily shown that this method is of big O of n. The method insert end can be implemented by using the method insert at. However, the method insert_end does not require the shifting of elements. Therefore, we give its definition directly as follows. The number of statements and hence the number of operations executed in the body of the method insert_end are fixed. Therefore, this method is of big O of 1. The method remove_at is the opposite of the method insert_at. The method remove_at removes an item from a specific location in the list. The location of the item to be removed is passed as a parameter to this method. After removing the item from the list, the length of the list is reduced by 1. If the item to be removed is somewhere in the middle of the list, after removing the item, we must move certain elements one array slot to the left because we cannot leave holes in the portion of the array containing the list. Consider the list of figure 2-6. The number of elements currently in the list is 6, and so length is 6. Thus, after removing an element, the length of the list is 5. Suppose that the item to be removed is at, say, location 3. Clearly, we must move list at 4 into list at 3, and list at 5 into list at 4, in this order. The definition of the method remove_at is similar to the method insert_at. It can be seen that the method remove_at is of order big O of n. The definition of the method retrieve_at is given next. The index of the item to be retrieved is passed as a parameter to this method. The definition of this method is as follows. This method retrieves the element from the list at the position specified by the location. A copy of the element at the position specified by location is returned. If location is out of range, an appropriate message is printed and null is returned. The definition of the method replace_at is as follows. The method clearList removes the elements from the list, leaving it empty. Because the data member of length indicates the number of elements in the list after setting the references of list in the range 0 to length -1 to null. We set length to 0. Therefore, the definition of this method is shown in this figure. This method removes all the elements from the list. After this, the length will become 0. As before, it is easy to see that each of the methods retrieve_at and replace_at are of big O of 1, and the method clearList is of big O of n. We now discuss the definition of the constructors. The constructor with parameters creates an array of the size specified by the user and initializes the length of the list to 0 and the max size to the size of the array specified by the user. The size of the array is passed as the parameter to the constructor, while the default array size is 100. The definition of the constructors are as follows. The default constructor creates an array of size 100. After this, the list points to the array, length is equals to 0 and max size equals 100. Next, constructor with parameters. This will create an array of size specified by the parameter size. After execution of this constructor, the list will point to the array, the length will be equals to 0, and max size will be equals to size. As before, it is easy to see that each of the constructors is of big O of 1. The copy constructor. Recall that the copy constructor is called when an object is declared and initialized using the value of another object of the same type. It copies the data members of the actual object into the corresponding data members of the object being created. Its definition is public ArrayList class with parameters ArrayList class other list. The method copyList makes a copy of a list into this list. The reference, say other list, of the list to be copied is passed to a parameter to this passed as a parameter to this method. If the list making a copy of other list is non-empty, then first it is destroyed. Similar to the method print, it can be seen that the copy constructor is of big O of n. You can write the definition